Let's determine t. So here we have t equals 560 times the definite integral of dx over x times of x plus 4 from the limits 3 to 6. So basically we have to integrate the expression 1 over x times of x power 4 and then substitute the upper limit and lower limit and then multiply by 560. So we can find the antiderivative of 1 over x times x plus 4 by partial fraction decomposition method. So let's write t. This equals 560 times the definite integral from 3 to 6. I write this given expression as 1 over x times of x plus 4 dx. So we are now going to write this expression in terms of partial fractions so that we can find the antiderivative. So let's discuss about this partial fractions, that is 1 over x times of x plus 4. According to the partial fraction decomposition method, we can write this as a sum of two partial fractions, that is a over x plus b over the another term, which is x plus 4. A and b are constants that we need to determine. So this is an equation of rational functions. On the left side, we have a rational function 1 over x times of x plus 4. On the right side, we have a sum of these two rational fractions. So to determine the values of a and b, we multiply both sides of this rational function by the common denominator, which is this expression, that is x times of x plus 4. And doing so, we get 1 on the left side, and this equals, we will have this first fraction multiplied with the term which it doesn't have uh, when compared with the least common denominator. So the denominator here is x, and the term it doesn't have when compared with the least common denominator is x plus 4. So a has to be multiplied with x plus 4, and similarly for the other rational function, this b has to be multiplied with the term which it doesn't have when compared with the least common denominator. So here it has x plus 4, which means it does not have x. So this has to be multiplied by x. Now we have to determine values of a and b. So we can put some random values for for x and determine the constant. Let's say if x equal to 0, we have 1 equals a times of 0 plus 4 plus b times of x is 0. So this becomes 0, and we have the equation a times of this is 4, so it is 4a. So we get a equals 1 over 4. Now let's put a equals negative 4. I'm sorry, we have to put x equals negative 4 into this equation. So we can solve for x, solve for b, and so therefore this equals 1 equals a times of negative 4 plus 4 plus b times of, replace x by 4. This negative 4 plus 4 is 0, so this term becomes 0, and we have 1 equals negative 4b. And so therefore solving for b, we get b equals negative 1/4. So we have determined the values of a and b. And this means we can rewrite this rational expression as a sum of two rational functions. So therefore 1 over x times of x plus 4, this is written as replace a by 1 by 4. So it is 1 by 4 divided by x plus replace b by negative 1 by 4. So this equals negative 1 by 4 over x plus 4. And this can be written as 1/4 times 1 by x, and here we write this as negative 1/4 times 1 over x plus 4. Now we can evaluate this definite integral. So I'm going to replace, we have t equals 560 times the definite integral from 3 to 6. So now we replace this 1 over x by x plus 4 as this expression. So therefore, this definite integral will become 1/4 times 1 by x minus 1/4 times 1 over x plus 4 dx. Now we can split this as two different integrals. That is, we have 560 common, so we put this inside the bracket, and this one is the first definite integral. Here we have 1/4 is a constant, so I factor out the 1/4, and then the definite integral from 3 to 6, the 1 6 1 by x dx. And in the second term, I can factor out the negative 1/4, the definite integral from 3 to 6, and this one is 1 over x plus 4 dx. We then close this bracket so that we can later on multiply 560. So we have 560 times this is 1/4. The definite integral of 1 over x is a natural logarithm of x, and this must be evaluated from 3 to 6. And then we have a natural logarithm. The integral of 1 over x plus 4 is natural logarithm of x plus 4, and this must also be evaluated from 3 to 6. Now observe that we have 1/4 common in these two expressions, which means we can factor it out. So therefore, we will have 560 times 1/4. And then we apply the upper limit and lower limit. So it will be natural logarithm of 6 minus natural logarithm of 3. And then we have here, we have already factored out the 1 by 4. So this will be natural logarithm of, if you substitute x equal to 6, 6 plus 4 equals 10. So this is natural logarithm of 10 minus natural logarithm of applying 3, that is the lower limit. We get 3 plus 4 equals 7. So this is natural logarithm of 7. We close this bracket. 560 divided by 4, this equals 140. So I write 140 here times, let's simplify this. This one is a natural logarithm of 6. And here we have this positive natural logarithm of 7, because we have a negative. When we distribute this negative with this negative, this will be positive. So I'm going to write the positive natural logarithm, that is natural logarithm of 6 plus natural logarithm of this one is 7. And then write the negative natural logarithm, that is negative natural logarithm of 3 minus negative natural logarithm of 10. We now use the properties of natural logarithm, that is we have 140 here. The sum of two natural logarithms we can write down as natural logarithm of the product of the numbers, that is 6 times 7. Then here also we can factor out the negative, and then write this as natural logarithm of 3 plus natural logarithm of 10. And in the next step, we can combine these two natural logarithms. So they will multiply, the numbers will get multiplied. That is, it will become natural logarithm of 3 times of 10, which is basically 42. So I'm going to write down in this next step. So this one is natural logarithm of 42 minus natural logarithm of, when we combine these two, we get natural logarithm of 30. Now, using the difference property of natural logarithms, you can combine these two logarithms, that is, right on 40. Natural logarithm 42 minus natural logarithm of 30. We write this as a natural logarithm of 42 over 30. This is absolute value. And this equals 140 times 42 over 30 is 1.4. So I write a natural logarithm of 1.4. We execute this expression using the calculator and then multiply the result with the 140. And when we do that, we approximately get the time equals 47.11. This is rounded to 2 decimal places. And we also put the unit of time, which is minutes. So this one is the time.